So input validation it's always a program that takes some sort of an input. صوتي واضح يا شباب ولا قبل شوي ما كان واضح؟
إلا واضح.
طيب. So input validation is some sort of a program that takes some sort of an input. Hello? So the input could be a command line argument, مثل you run something and then you give it something in the command line. Could be environment variable. احنا نعرف دائما software takes a lot of input from environment variables in the system. And we'll take some examples. Could be, you know, a function call that you give it parameters. It could be some configuration files. It could take input as a packet in a networked architecture that it takes it, you know, from one place to another. And in web applications, sometimes you take it, you know, a form, an input from the user, a scripting language, whatever it is. There is multiple ways where a program takes an input, and this is the power of programs. It takes an input and do some processing and gives you back an output. So what does an attacker want when they, you know, when they want to use that input to cause some violation, right? So it could either crash the program, it could execute some arbitrary code, or it could obtain some very, very sensitive information like, you know, keys or whatever. يعني heartbleed مثلا, as an example, one of the most famous issues with SSL and TLS. So with certain input, it gives you everything that the server has, including the private key of the SSL. So that was a very, very well-known attack a couple of years ago. So how do you evaluate inputs? So there are two ways to evaluate inputs. The first way is you do blacklisting, which basically says, here are the couple of things that are in a blacklist, things that are not allowed, right? All those things are not allowed. You know, all of those bunch of things are not allowed. This is not allowed, this is not allowed, and this is called a blacklist. Always the biggest challenge with blacklists, do you have the list of everything that is not allowed? An attacker can be, you know, maybe if you say, you know, like many things, you know, you put it, you can't, in many cases, you can't have the list of all the things that are not allowed. And the attackers will always find around this. A better way is what is called whitelisting, which means basically saying these are the only things that are allowed. And when you get something, you say, is this allowed or not? So it's the complete set of opposite, which is saying everything is not allowed unless it is 1, 2, 3, 4, 5. And the difference is you can, if you can specify all the things that are allowed, this is amazing. لأنه basically you can just specify this list, and whatever the attack wants to do, they could do it. The problem is this is in many cases reduces the flexibility of the program. It reduces the usability of the program. لأنك أنت you're limiting fundamentally, you know, what the program can do, what kind of input. This is kind of like, يعني, the two ways to do this. A third way, which is not in the slide. So if we take here the spectrum of inputs, this is good things, this is bad things. So whitelist is saying, you know, these are the things that are allowed. And then all the world of bad things are not allowed. The blacklist saying, these are the things that we know that are bad. And then the rest is either we didn't include it or it is allowed. بس تلاحظون في this set that the blacklist doesn't work. There are bad things, but we don't know them. We did not add them here, right? So this list is fundamentally where most of the security problems come from. So this is where the concept of a gray list, right? So a gray list, يقول لك يا أخي, do a white list of all the things that are allowed. So if the first thing that you do, check. Is it allowed? Perfect. Or actually, you actually start here. All the things that are not allowed, if it's allowed, if it's not allowed, close. Is it allowed? ممتاز. If it's in the middle, be cautious. Be careful. Don't always allow it, but don't always leave it.
يعني قصدك ان نحطها بمحدوديه يا دكتور تكون في النص صح؟
بالضبط. نحطها in a way where it's not blocked, but it's not fully trusted. So ممكن we do extra checks, we do كذا, we run the program مثلا under less privileges, we reduce the time, we do many things, right? But this is the concept of a gray list. So the best thing is basically to do whitelist if you can. If you can't, you basically do a gray list, and you should always be able to do a gray list. You should try to avoid as much as possible to only do blacklist. لأنك عندك هذا all this data, you're treating it exactly like a whitelist if you don't use a gray list. You're treating it as trusted. So أحسن إنك you do, if you're not doing a white list, do a gray list. So let's look at what could go wrong in a command line world when we don't do a proper input validation, right? So let's say this is a command line function written in C. It takes 2 arguments. The number of command line arguments, right? So if we say هنا مثلا, مثلا, if we say CD R to W, right? So this is a command line argument. C هنا argc becomes 3, right? And argv becomes a string of strings, right? لأنه CD is actually string, 2 letters. R مثلا, let's say this is RI and WX, right? Another string of 2 letters. So this is 0, this is 1, this is 2, and each one of those is a string. So then we have a buffer, which is 1024 different bytes. And what we say is print on the screen, right? No, not like copy, not print, copy, right? And using printf, print inside the buffer, right? يعني this main program takes this second argument and print it again. Hello? So this second argument right now, it's actually in argv1. It puts it inside this string and then takes all of this string and put it inside the buffer. So we already know the first 1, 2, 3, 4 characters in the buffer is CAT space. بعدين the string starts to be written. You notice that now we don't check the size, right? So we just said anything here. So if this one is larger than, okay, 1024, so we have 4 things gone. So we have 1020, and we know the last bit of a string is always \0. So we have 1019. If this variable is larger than 1019 bytes and 1019 characters, if we do this, system and execute inside the buffer, this will cause the program to crash at best. If the attacker is careful, they might start to do some really, really interesting stuff, right? So this can be crashed, but also more intelligently, what an attacker can do, لاحظ إنه هنا what this guy wants to do, take the second argument, and احنا نعرف if you say cat in the command line cat, and you put some text, you're just telling the system to print this text تحت. حلو? So if an attacker, give the second argument by saying, the second argument is, cat مثلا يعطيك string ABC and puts a semicolon and then do, sh or bin, right? sh. So an attacker gave this as an input. When this function basically starts to print this out and execute this, cat, this get printed, but also now I can run a shell because I did not check the input. المفروض الانput ما في semicolon. Why? If you have a semicolon, it's telling the operating system, I am putting execute the first command and then I'm executing the second command. And this is like super dangerous. The second part of this is command line problems. The second part of this is basically starting to play with environment variables. When any software takes some environments variables from the system. For example, this variable tells you where is the library of of different system-wide functions. The path is also gives you the domain of also some shell functions, and IFS tells you what is the space. So we know in a space, the command line always wants to know how to ignore space. So space is a space that could be ignored. Tab is also a space that could be ignored. So all of those go into the IFS to tell IFS, look, if you see tab or space or whatever, these are things that you should be ignoring and not using as part of your input. So an attacker, for example, so here is an example that we're going to go through. So assume إنه عندنا set user ID program, and we will talk later about what a set user ID is, but assume إنه we have, if you already know what a set user ID program is, that loads dynamic variables or dynamic libraries. Libraries are in this environment. So Unix basically use this environment variable to search for every possible library. Hello? So if an attacker can include this in this variable and start to add additional libraries and his own copy, like let's say for example, ls, right? ls, this variable puts the location of when the system sees ls, it needs to know where is ls. So how does it know where ls? So until you're in Unix or Linux and do ls, right? Which is list. So the computer needs to know where is ls. So it goes to this, you go look, where do I search for ls? And it tells it search for it in /bin/ kida, search for it here, and puts the list of everything, right? And then the computer starts to go and find, and if it finds a binary called ls, it executes ls. So what if an attacker is able to change this and remove everything and then put a new directory here called temp/temp/attack, and then create a new binary isma, ls, a binary file, an executable isma ls, But what this does is open a shell and opens a back network to an attacker. So when a normal user is just typing ls, but his library has been changed, it goes and searches here, it finds this, and it executes, and then it opens a shell. And it's a simple ls function. However, because I changed the location where ls can be found, an attacker can manipulate how this how the computer behaves, right? For this is one way how you use environment variables. Another environment variable مثلا اللي قلناه اللي هو path variable, right? So path basically tells the operating system, every user has path, it tells the operating system what is the code, what is the user specific home path, current directory they're in. And the computer, احنا قلنا قبل شوي, the computer first search for LD library path. But before it searches for system-wide libraries, whenever it executes something, it searches for this. So if as a user, you can create your own version of ls, and you say, when I say ls, to run this version, my own version of ls, not the system-wide version. Hello? So the computer first starts with path, and then go to the LD library, whatever اللي شفناها in the previous slide, right? So if a user wants to override how ls works, they can do that easily. Just create a program and a binary called ls, and put it in the directory where your path is. And this is usually your home path, right? But if the user do this, they want to hack themselves, it's up to them, right? Like they could do whatever they want. But imagine an attacker, the user doesn't override ls, but the attacker goes and find path for the user and change it to another path, right? And put يعني مثلا ممكن temp, hack, and write ls. So they did not change the system-wide library, and this might break a lot of things. They only changed the path for this very specific user and inject new binaries that can manipulate stuff. And then what happens, they can then start to do really, really funky stuff that the attacker chooses to do. The third type of an attack is basically playing with the IFS variable. زي ما قلنا, IFS variable tells you what a white space is. And then when it's a white space, whenever there is some command line functions, it is telling the computer to ignore all of those functions. So let's say the attacker again cannot change the path, cannot change the LD path, right? But what they could do, they could take S and inject it in the IFS. So when a user is doing this, the system tries to interpret this and it goes, like you could do this and also leave spaces. The system, fine, understands this and ignore all the spaces. But if I add S as part of what is a white space is, the system now ignores S. So execute this as system L. And the attacker now can introduce a new binary called L and put it somewhere where when the system tries to find L, then they find this L it's a new binary. I'm not overriding something. I am not changing any binary. I just simply made S part of the IFS, which needs to be ignored when you know exactly what are a white variable or a space variable is. Okay, so maybe should we talk about, yeah, no, let's stop here, and if any one of you has any particular question.